Hi there. Today we will be covering how to factor quadratic expressions. More specifically, we'll cover the different factoring methods, when you should use each technique, and a few extra tips and tricks along the way. What you can see here will make a little bit more sense at the end of the video, and I will break this down step by step at the end of the video. But basically, this is the workflow to address any factoring problem you may see. In red are the different factoring techniques you may use. And if you want to quickly jump to any of these factoring techniques, I've linked to additional videos down in the description below, as well as in the top right corner right now, and you can quickly jump and get a refresher on one of these techniques if you want to learn that really quick. But again, in this video, I will be covering all of these techniques, so please stick around. The first type of factoring is called common factoring, and this should always be the first step of any factoring problem. Basically, what you do is you look for common terms that are factorable from all terms in your expression. So, for example here, we can see that both from 8x squared and from 4x, we can divide out a 4, as well as divide out an x. And what we're left with is 4x multiplied by 4x plus 1. Now, interestingly, this is already in factored form. If I write it a little bit differently, but don't change the value of the expression at all, you can see this is already in factored form, and we're actually done. But this isn't always the case, and you don't always create a perfect factored form right away. So, for example here, we can factor out a factor of 2, but we're left with something that still resembles standard form. And this is actually as far as we can go with common factoring, and we'll have to use a different type of factoring method to go one step further. Finally, you always want to check if you can common factor your expression again. So, for example here, we could pull out a factor of 3, and we would turn the expression into something like this. But once again, you can see our non-factored expression can still be common factored again, and we can actually pull out a factor of 2. If we do that, we see that we actually could have just pulled out a factor of 6 from the start, but you don't always jump to that number right away. So always check after you've done a common factor if there's still more common factoring you can do, as this is very important to handle any problem. The next type of factoring we will cover are known as simple trinomials. Now, simple trinomials are indicated by having an x squared coefficient of 1. So, something like this has an x squared coefficient of 1. Now, normally it is not written, but there is a 1 that exists there. But mostly you're just looking out for, is there another number in front of your x squared term that would make it not a simple trinomial? So, how do we factor these? Well, what we're going to do is find two numbers that multiply together to give us our c term, and add together to give us our b term, seen here. Unfortunately, this does rely on a little bit of guess and check. So, for example, -2 and +2 do multiply together to give us -4. However, when we add them together, we do not get +3. So let's try a different set of numbers. Well, we could try -1 and +4. This satisfies our first expression. And -1 and +4 again will add to give us +3. So these numbers look like we're good to go. Now, to give you a little bit of advice when handling these problems is sometimes you will have to guess and check quite a few times. You'll start to develop habits on how to kind of quickly jump to the correct numbers, but here's a foolproof way of finding your numbers. The first thing you want to do is determine if your product, so the numbers that will give you your c term, if that c term is negative or positive. If it's positive, you know both numbers will need to be negative or positive. And if it's negative, you'll know that one number needs to be positive, whereas one number needs to be negative. And this can kind of help hone you in on what numbers you might be looking for. For example, if we wanted +6, we could do +3, +2, -3, -2. Or if we wanted -6, we could do +3, -2, -3, +2. The next thing you want to do is list out all the possible factors. So what I find the best way to do is start at 1 and go up until you've covered all the factors. So, for example, to give us 6, what we could do is 1 times 6 or 2 times 3. Now, using all of this information, we will cover every possible combination of products that will give us our answers. And it can be a simple game of guess and check, but this is a foolproof way and you'll always find the answer. So what do we do once we have these numbers? Well, as I showed on an earlier slide, we want to go from standard form to factored form. And what's really important is this d and e term in our factored form. Interestingly, the two numbers we just solved for that will multiply together to give us c and add together to give us b, these are your d and e terms. So to simply factor this, we turned it into an x minus 1 multiplied by x plus 4. We just simply sub our d and e term into the expression. Now, one thing that's very important to note is you always want to check if you can common factor to create a simple trinomial. So, for example, this does not have an x squared coefficient of 1. It has an x squared coefficient of 3. And this is obviously a problem. However, the first step we should always do is see if we can common factor. And sure enough, if we common factor out 3, we've actually created a simple trinomial. Now, I chose this to be the same simple trinomial I listed above, and we now know how to factor that. So now we factored something that looked a lot more confusing, but it really broke down to be a common factor and then a simple trinomial expression. The next method we're going to be covering are known as complex trinomials. Now, complex trinomials, as I kind of alluded to in the previous slide, are polynomial expressions where the x squared coefficient is not equal to 1. So, for example, something like this, we have an x squared term of 3. So, to solve these, what we're going to do is very similar to a simple trinomial. We're going to find two numbers that multiply together, but this time they're going to multiply together to give us the product of a and c. So in this situation, 3 and 8, and that's 24 in this situation. We next want to find two numbers that will add together to give us our b term, just like a simple trinomial. Now, as you can see, these numbers do tend to get larger, so it can be a little bit trickier to solve. I'm going to jump right to the answer in this situation, and what we're looking for here is -6 and -4, which will multiply together to give us positive 24, as well as -6 and -4, which will add together to give us -10. Both are satisfied. Now, once again, these same methods I talked about in simple trinomials apply here. So we want to list out all the different factors we can do and both their positive and negative values that might work. So in this situation, we were looking for a positive 24, so we'd want to use two positive or two negative numbers. And as I mentioned, when you start to get into these larger numbers, there starts to be a lot more factors that you list out. So here it could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. And so it can be a little bit harder. There's a little bit more guess and checking to do. And this is why I showed on the previous slide, we always want to jump from something that's a complex trinomial into a simple trinomial if you can common factor. It makes life a lot easier. But complex trinomials are still very doable, as you can see here. They might just take a little bit longer to solve. Now, unlike simple trinomials, we can't just immediately jump to factored form. What we want to do is break down our b term into those two terms we just determined. So as you can see, -10x is the same thing as -6x and -4x. We didn't change the value of the expression at all. We just broke apart that b term. Then what we can do is look at our first two numbers and our last two numbers, and what we can see is that both of them actually have a common factor. What we can do is we can common factor out an x minus 2 from each of these terms. Now if we pull that out of both terms, what we're left with is the remaining 3x minus 4, and this has now been factored. We know the final result, and this is great. But once again, this was a few extra steps, so we always want to try to create a simple trinomial with common factoring, because these will take you a little bit longer, but this is exactly how you solve these problems. As I mentioned, you always do want to try to create a simple trinomial. So something like this I showed on the previous slide, we can common factor out a factor of 3, create a simple trinomial, and then we can do our easier simple trinomial factoring. The final type of factoring method we're going to cover is known as difference of squares, and it's a relatively unique type of factoring method, and it requires very specific circumstances before you can use it. However, if you can use it, it is a very effective technique. So the first question I will ask is, what happens if your expression has no x term? What this actually means is that your b value is 0, and so the x term does not appear, and you're just left with ax squared plus c written in standard form. To give that a little bit more understanding, what that would actually look like is something like this: x squared minus 16 or 4x squared minus 9. So difference of squares can be used under these circumstances some of the time, and it requires your expression to be written specifically as a squared x squared minus c squared. So here's a few of them that we can run through. For example, x squared minus 16 satisfies this equation, as it could be written as 1 squared x squared minus 4 squared. Again, there can be a coefficient in front of your x term as long as it is a square, so this could be again written as 2 squared x squared minus 3 squared. Something like this, however, does not work, as you very specifically need it to be minus c squared. So if it's a positive, you cannot use difference of squares. Additionally, something like this, 2 is not a square, so it cannot be used through this method. This final one might not look at first glance like it would work. However, always remember you should start with common factoring. And if we common factor out of 2, we've now created an x squared minus 4, which does satisfy this condition. So what do we do to do this type of factoring? Well, simply the formula written here, a squared x squared minus c squared becomes ax plus c times ax minus c. So, for example, x squared minus 16, you could write as 1 squared x squared minus 4 squared, so it does satisfy our conditions. And we can now just write that as x plus 4 and x minus 4. Something with a coefficient in front of the x squared, for example, can again be broken down in this situation as 2 squared x squared minus 3 squared. And once again, we can simply follow this formula and create 2x plus 3 and 2x minus 3. And we've simply factored these. Now, the next question you might run into is, how does this actually work? How are we doing this jump? Well, let's go from factored form to standard form and see how this actually works. What we can see is in our condition where we had 2x plus 3 and 2x minus 3, if we expand this out step by step, what we can see is our x squared, or sorry, not our x squared, our x terms will actually cancel out. The way these are designed is they will cancel out, and that's why we don't see a b term. And if we simplify this up a little bit, what we can see is this is how you jump from a difference of squares expression into its factored form. When you expand them, you'll always cancel out your x term, and that's how this works. This is always a very important check to do to make sure you didn't mix anything up. Always try to expand your factored form and see if you get back to the correct standard form you started with. So this covers all the different types of factoring methods you might use to address a problem. Now the question is, how do we know when to use each type of factoring method? I did outline when each one can be used, but I have a simple flowchart that will really help you address a problem, follow through these steps, and know exactly which factoring method you should be using. So let's move on to that. This was actually the slide that I started with, and while I showed it all at the start, let's go step by step to go through this. The first question you want to ask is, are a, b, and c all divisible by the same term? For example, on the left here, they could all be divided by 2, whereas on the right, there is no common factor we could pull out of these. If there is a common factor you can pull out, this is when common factoring comes into play, and as I mentioned, you could common factor out a value of 2 from this expression. The next question we want to ask is your trinomial now factored? So for example, on the left, when we pull out a 4x through common factoring, we actually now have this in factored form, whereas on the right, we pulled out a 2, but we still have a factor that's, or my apologies, a trinomial that is in standard form, more or less. So if we did factor it completely, you're done. You don't have to go any farther, but if not, we have to keep going. The next question we want to ask is your expression in the form a squared x squared minus c squared? So for example, on the left, this does follow the a squared x squared minus c squared expression, whereas on the right, this does not. This is very different. If it does follow this format, we can then use difference of squares factoring, and again, now we're done. However, if it does not follow this format, we have to keep going. The next question we want to ask, and this is actually the final one, is the coefficient a 1? And this again is the x squared coefficient. For example, on the left it is, and this allows us to use simple trinomial factoring. If not, if the coefficient is not 1, we are then going to use complex trinomial factoring, as you can see here. Now, if you follow this flowchart, it will break down any problem you have and exactly how to factor it. And this is the most efficient way of addressing any problem. The only question that can arise is, what happens if none of these work? And that's very interesting. Some expressions can't be factored. There's no way to factor them through these techniques. And that's something I'll cover in a different video. But for now, thank you for watching, and I hope this helps you in your studying.